Hey everybody. Here is our last set of notes. At least for the 2025 school year. We'll see if we get farther later on. So if you're watching this later, it might not be the end. But up at the top here, we're going to talk about our last type of identity. We've talked about reciprocal identities and quotient identities so far. This is about Pythagorean identities, which obviously is linked to the Pythagorean theorem and reference triangles. Up at the top here, it says now that we've covered the R's and Q's, reciprocal and quotient, we're going to cover, or prove, sorry, the three different Pythagorean identities using a referenced right triangle in quadrant 1 for the unit circle. This will give you a strong foundation of why the identities are what they are and will help you in working problems that need to use any of these three identities. We will also include the three forms of each because they can be rearranged. So we're going to put them in here. And then they're also written on your paper, your half sheet. Let me find where that is. Oh, perfect, right here. They're also on here in that bottom corner where it says Pythagorean identities right here. So you'll be allowed to use this in pretty much everything. So don't worry about memorizing, just worry about understanding. Here we are given a quadrant 1 of the unit circle. What we're going to do is draw a reference triangle in quadrant 1. And we'll call our unknown angle theta. What we do know about this triangle is it has a x value of x, a y value of y, and then it has a radius equal to 1 because the radius is on the unit circle because it intersects with the circle. And we also know that to find the sides of a triangle, you would use a squared plus b squared equals c squared, or in this case, x squared plus y squared equals r squared. Here we know r is 1, so that'd be 1 squared. And then for x and y, if you look over here, oh, excuse me, we know that sine is y and a cosine is x. So instead of x squared, I could use cosine squared. Instead of y squared, I could use sine squared. And then r squared is 1 squared. 1 squared is just 1. This here is our first identity. It is called P1. And we're going to put it up here in this box where it says P1. Equals 1. So for any problems you have that you're trying to simplify that have a plus sign in sine and cosine, or a plus sign or sine and cosine, that's the one you would use for that. An example would be looking at number 5. Down here we have sine and cosine, so we're going to use P1 for that. You could rearrange these. Right now we know what it looks like when it's equal to 1. We could also make it equal to cosine squared, or we can make it equal to sine squared. And we're just going to figure out how to solve for each of those. So if I wanted to get cosine squared by itself, I'd move the sine squared over here. It's positive, so I'd subtract it. So I'd have 1 minus sine squared. Then if I want to get sine squared by itself, I'd move the cosine squared. Cosine's positive, so it'd be 1 minus cosine squared. And here are the three options. Now, what you're going to do when you're working through your problems is you're always trying to get rid of the plus or the minus sign. These are what will get rid of our plus and minus sign. See if you plug, or if you see one of these, you can get your answer just as one term. That's the goal there. Because once you have one term, then you can apply these ones here to simplify down to just one ratio total. The problem is, if I were to stop right here, I would only be able to solve questions that had cosine squared and sine squared. I wouldn't be able to do anything with ones that had tangent, secant, cosecant, or cotangent. So what we're going to do is rearrange P1 into the other trig ratios to help us then get P2 and P3, so we could apply those to questions to simplify those as well. So to get P2, we're going to take P1, which was cosine squared plus sine squared equals 1. We're going to divide by cosine squared. And when I do that, I will end up with cosine squared over cosine squared plus sine squared over cosine squared equals 1 over cosine squared. And then I'm going to use my other identities to simplify each of those individually. So looking at our first fraction here, anything divided by itself is 1. Then I have a plus sign. And then we have sine divided by cosine. So looking just at this fraction right there, we're going to look for sine over cosine. I see it right here. So it's tangent according to Q1. Oopsie. So per Q1, sine divided by cosine is actually tangent. And because it was squared over here, our tangent would also be squared. And then we have an equal sign. And then I have 1 over cosine squared. So I'm going to look back over here. And we're looking for 1 over cosine. You can see that is right here. It's R5. And that is secant. So per R5, 1 over cosine squared would be secant. And that's also going to be squared, obviously, because the cosine was squared. And this is P2. So this is the one we'll use if our question has tangent or secant and a plus or a minus, because the minus we can just rearrange. Let's write that up at the top here. And P2, 1 plus tan squared equals secant squared. There we go. Now I have solved for secant here. I would also like to solve, there we go, for 1 and for tan squared. So just in case I have any of the other options, I can solve for those two. So to get the 1 by itself, you'd move this tangent over here. It's positive, so we would subtract it. So it would be secant minus tangent. And then to get tan by itself, we'd move the 1. The 1 is positive, so I would subtract it. So I end up with secant minus 1. Like that. And there we go. So far, if we had a problem that had cosine, sine, tangent, or secant, and a plus or minus, then I'd be able to simplify. We still wouldn't be able to do it, though, if we had a cotangent and a cosecant. And that's going to be down here for P3. If you want to go ahead and pause and see if you can figure it out. We did do that in class where people got it on their own. So go ahead and pause, see if you can get P3, and then come back when you're ready to check it. Here we go. Go ahead and check your P3. It said to divide, sorry, by sine squared. I did that right here. That got me here. And then I just identify each of my fractions using my half sheet. And it says cosine over sine is Q2, aka cotangent. Sine divided by sine, anything divided by itself is 1. That's where I got my 1 there. And then equals to 1 over sine. According to our 4, 1 over sine is cosecant. And there we go. Let's put this up in our top box. Go. I'm just going to highlight there. So we're going to here. We got 2 more things to check out. Let's see if we can get equal to cotangent squared and equal to 1. If I'm trying to get cotangent by itself, I'd move this one over here. It's positive, so I better subtract it. Like that. And then if I want to get 1 by itself, I'd move this one over here. It's positive, so I would subtract it. And there we go. So here are the 3 forms. The reason they have multiple forms is because they have a plus or a minus sign. They have multiple terms. These over here only have 1 term on either side. 1 term, 1 term, 1 term, 1 term. So same for here. 1 term, 1 term. The reason these are obviously moving around because I got 2 terms on one side, so I could rearrange with the 2 terms. But here are all of the identities right here in the corner of our half sheet. Here, here, and here. Okay, let's try to apply. Up at the top on our practice sheet says all Pythagorean identities include the trig functions squared. This is not true for the reciprocal and quotient ones. This is something when working on problems to help you decide what steps to use to simplify. Please please pay close attention to parentheses and operations in the problems. I did mention here, obviously, already that we're looking at operations. I'm going to highlight that word. Operations as in add, subtract, multiply, divide, and that everything is squared. Those are the two things you're going to look for if you can and should use a Pythagorean identity. In my opinion, the easiest one to look at is the operations. If you see a plus or a minus sign, you have to use a P1, P2, or P3. There is no other way to simplify down to just one term, aka one ratio, without applying P1, P2, or P3. I'm going to put that up here. Must use P1, 2, 3 if there is any plus, sorry, plus or minus, I'm fine, plus or minus signs. While I do. Here we go. Good, let's give it a go. Now what you're going to do is pretty much any kind of math you can figure out to rearrange things to fit what you're trying to use. On this first one here, number one, I already told you, well, on this whole page, I'm telling you how to get them all. Obviously, for questions that are just in the wild, you're not going to be given a hint, but I figured it was appropriate for this first set of notes. So it says simplify by using a GCF. Just a reminder, GCF stands for greatest common factor, and that is something that can be divided out of all of the terms that you're looking at. So looking here, you ask yourself, do we have a plus or a minus sign? We do. So we're going to have to use P1, P2, or P3. Next, we're going to see if we have anything squared. We do. We have a cotangent squared. So I'm going to use my half sheet. Let me actually move it over. I'm going to scooch it. There we go. And I'm looking here. I have cotangent squared. So which one of these am I going to use if I have cotangent squared? According to the paper, I'm going to use P3, one of these, for cotangent squared. The problem is I don't have 1 plus or minus cotangent squared. I can't remember if it's plus or minus. Looking over here. 1 plus. Yeah, I don't have 1 plus. I just have cotangent squared and then some sign. Obviously, none of these have a cotangent and sign. So we're going to have to get rid of the sign somehow. You'll notice both of our terms have a sign, which means I could take out a greatest common factor of sign because they can all be divided by sign. So if I do that, I'll put the sign up front. And then sign here divided by sign. If I were to divide it out, that makes 1. Anything divided by itself is 1. I have that plus sign. And then if I divide a sign out of here, those will cancel. And I would just have cotangent squared left. And there we go. Now we reevaluate. We have a squared, a plus, and we have a 1. So let's see if that matches our paper. Get over here. It does right here. See right there? We have that, which means instead of writing this, we could instead write this, which would get rid of our plus sign. That's the goal, because you can't simplify around a plus sign. So we use P3. And per P3 on our paper, it says 1 plus cotangent squared is the same thing as saying cosecant squared. Like that. Now I want to simplify. I no longer have a plus sign, right? I'm done with the plus signs. Once your plus signs are gone or your minus signs are gone, when your signs are gone, everything's just being multiplied or divided. Then you can just apply R's and Q's, so reciprocals and quotients, because those don't have any plus or minus signs. And that's normally what you're going to do is just turn everything into sine and cosine, so it's easier to simplify. I already have a sign here. I'm going to change this into sine or cosine if I can. Let's look over here and see what we can do with that. So I currently have a cosecant. That's going to be right here. That can become 1 over sine. So that is R4. Right here I got R4. And R4 is telling me that I could do 1 over sine. Because my cosecant squared, my sine would also be squared. Good. And then from right here, I could cancel. I got 1 on top and 2 on the bottom. So I got the 1 gone on top, and I still have a sign left on the bottom. So across the top, if I just simplify, I have 1 times 1 is 1. Across the bottom, I have a sign. And then we still want to keep going till we get down to just 1 ratio. And we actually just used this one, right? We just went from cosecant squared to 1 over sine squared. And then now we're at 1 over sine. So we could apply R4 again. to get to just cosecant. And there we go. That's the answer. Huzzah. Let's do it again. Okay, number 2. First thing we do, identify if we have a plus or a minus sign, because we have to use one if we do. We have a minus sign, so we must use P1, P2, or P3. The problem you can see here is we don't have anything squared. So we got to figure out how to make something squared. If you're looking just normal math, right, we could distribute out that sign, because on the outside of those parentheses, which says here, simplify by distributing. So if I put an arrow here, I have sine times cosecant, would just be sine cosecant, minus, then I have sine times sine, that would give me sine squared. So we're making our way closer to using a P1, 2, 3. We have a minus sign, that's good. We have a sine squared now, also good. According to our paper, we'll use P1 for sine squared. Right here. The problem is, for this sine squared to work, I either need to have 1 minus sine squared or sine squared plus cosine squared. Right now, I have neither of those. I have sine times cosecant. So this is unhelpful currently. We can try to simplify this. If to do that, I would just transfer this over into sine and see if maybe they'll multiply or cross out or something like that. And I'm going to look over at my paper again. I'm looking to change cosecant. This one says cosecant, that is R4. So per R4, cosecant's actually 1 over sine. And then I still have my minus sine squared here. And now I have sine times 1 over sine. These would cancel. I would just have a 1 left. So I have 1, and then I still have my minus sine squared. You can see now this does match our paper. So I have 1 over sine squared now. And you can see it's right here. 1 over sine squared is actually equal to cosine squared. Sorry, wrong way. So P1 says this is actually cosine squared. And now since it's down to just 1 ratio, that's the answer. There we go. Magic. So just to summarize one more time, because you're about to try one by yourself. Step 1, do we have a plus or minus sign? If the answer is yes, we must use a P. 1, 2, or 3. Second question, which one are we going to use based on what we have squared? If we have nothing squared, make something squared. If we have something squared, figure out which P1, 2, 3 we're going to use, and then morph yours into that by using mathematical logical things, such as multiplying, dividing, or simplifying. Okay, I'm going to give you an easy one. Try number 4. Number 4 is very simple, very fast. You try. You're going to use 2 of your P's this time, just as a hint there. Okay, so pause, come back when you're ready. Here we go. So that's actually just one step. Well, technically 2 if you're going to apply both your P's. So the top had 1 minus cosine squared of y. According to our half sheet, that is P1, and P1 tells us that 1 minus cosine squared is actually equivalent to sine squared. You can see that right here. And then on the bottom, denominator, hello, we had cosecant squared minus cotangent squared. You can see that right here. That is equal to 1. And that's what I did here. So that turned into sine squared, that turned into 1. Anything divided by 1 is just the other number. So there we go. So not always bad, not always crazy. Try number 3 next. Number 3 is kind of a morph, honestly kind of a morph of these two. But you are going to have to switch some stuff around and take a greatest common factor. So give number 3 a go, and then unpause when you're ready to check number 3. Here is number 3. In the numerator, we had a minus sign, so we must use a P in the numerator. We did not have a minus sign in the denominator, so that one's not going to have a P. Up in the top, we had sine minus sine times cosine squared. What I did here was say, well, they both have a sign. I could try to take that out because it's not squared. I need it to be squared to be able to use it, but I do have a squared cosine. So I divided everything up top here by sine, right there. So I took the sine outside, open up my parentheses, sine divided by sine is 1. Sine cosine squared divided by sine, the sines cancel, and I get cosine squared. So now within these parentheses, I have 1 minus cosine squared. That does match our half sheet. It says that P1 is 1 minus cosine squared, and it's equivalent to sine squared. So I just change that over here. And then I had a whole bunch of signs, so I'm just going to cross out what I can. I got 3 on top total and 2 on the bottom. So 2 are going to cross out the top and 2 are going to cross out the bottom. So I have 1 left on top, and that is the answer. Good. Let's look down here. So these bottom 3 here all involve needing to simplify by dividing out a -1 at some point in the question. The reason we would do that is if our question looked right, but it had the wrong signs. So what I mean by that is if you're working a question and you figure out that you actually have this. Oh, sorry, that's wrong. 1 minus cosecant. There we go. Okay. Let's say you had this. This does not match right here. You need to have a positive cosecant squared and a -1. You have the opposite. So what you would do would be divide everything by -1, and that would change the sign of these. So it would then match, and you could simplify by transferring it over into this. So when we have a -1, or when we divide by -1, take it out like a GCF. The reason we're doing that is so we can change the sign, and then it will match the actual identity instead of being slightly off. We'll do number 6 together, then you can try number 5. So look at number 6, it says simplify GCF of -1. The top has a minus sign, so we're going to use a P up here. The bottom also has a minus sign. We're also going to use a P down there. So we'll use a P on top and a P on bottom. They are not going to be the same P because we have different ratios here. On the top, I have secant squared minus tangent squared. Based on this, that would be P2. And that actually is already in the correct format. Secant minus tangent squared is equal to 1. So in the numerator, I'm just going to apply P2. And per P2, the numerator is actually equivalent to 1. Looking at the denominator, I have cosine squared minus 1. I'm going to look here to see what I'm going to use. I know I'm going to have P1 because I have cosine squared. Here I have cosine and sine. I'm missing a sign. So I'm looking for that just has cosine and 1. That'd be right here. But this says 1 minus cosine squared. I have cosine squared minus 1. So I need to flip-flop them. But if I do that, I'm going to end up like this. See, it's going to be the wrong sign because I have a -1 and a positive. So that's where I would take out the -1 to switch the sign. So right here, let's flip-flop that. And that would end up with -1 plus cosine squared of x. And now they're the wrong sides. So I'm going to take out a GCF of -1. And you can see that's going to switch the sign because -1 divided by -1 makes a positive 1. And then positive cosine divided by -1 makes a negative cosine. And that gets me to here. Now, in the bottom, I still have that minus sign. I have 1 minus cosine squared. And we already checked per P1, 1 minus cosine squared is actually sine squared. So that would get me to here, like that. You could also write this as this, like that. Same thing. Or you could put the negative sign on the top if you wanted to. It doesn't matter. The negative can go anywhere because it's just multiplying. It's not adding or subtracting now. The last thing I'm going to do is get this into just one ratio. I have 1 over sine squared. Up here, looking at my r's, that would be, right here. So cosecant is actually equal to 1 over sine, and that is R4. And since the sign is negative, it'd be negative cosecant, and then because the sign is squared, it would also be squared. So negative cosecant squared. And there we go. Perfect. So biggest thing to notice is double, triple, quadruple check that it matches the paper. If it looks really close but isn't exact, you probably have to divide by a -1, and that will switch your signs to then make it match. Perfect. Okay. I think that 7 is a little bit harder, so we'll do 7 first. pause, try 7, and then come back when you're ready. I am going to give you a hint. 7 has a numeric answer and not a ratio. Here is the answer. You should have -4. The way we got that, and you might have done this swapped order. You might have done the take out the 4 first and then have to take out another -1. That'll give you the same thing. You should end up with -4 no matter what. What I did here was I looked and I said, well, we have a minus sign, so I must do a P1, P2, or P3. And then I saw we had cotangent and cosecant squared. That takes us to P3. But, excuse me, according to P3, to do, if I want to have both of them, because this is the only one that has both, it should be cosecant squared minus cotangent squared. And I had the opposite. I had cotangent minus cosecant. So I had to flip them around. I did that right here, from there to there. Now I noticed, well, because I flipped them, they're in the different, well, same sign, but like the signs are obviously wrong now. So I took out a negative because this had to be a minus and it was currently a plus, so I want to change it. This had to be a plus, it was currently a minus. So I took out the negative, and then they both had a 4, so I took out the 4 as well. So I divided everything by -4. That gives me cosecant squared here. And then this +4 divided by -4 is -1. That's where that negative sign comes from right there. And then, according to P3, cosecant squared minus cotangent squared is actually equivalent to 1. And then -4 times 1 is -4. Perfect. Okay, try number 5 last here. And then come back when you're ready to check it. Here is our answer. In the top, I did not have a plus or a minus, so I just kept my negative tan the same. In the bottom, I did have a minus sign, so I knew I had to use a P. I had cosine squared and sine squared, so I looked over here, and that was P1. But my P1 has sine squared plus cosine squared over on the paper, and then over here, we did the cosine squared first. So my brain tried to make it into this one, so I flipped it around. You didn't actually have to flip it around because it's being added. For the ones that are subtracting, it does matter which one is in front. But because these two had the same sign, you didn't actually have to flip it. My brain wanted to, so I did. Either way, it's still P1 because cosine squared plus sine squared is the same thing as sine squared plus cosine squared, because 2 plus 1 and 1 plus 2 are both 3. The reason it wouldn't work in all the other ones like this one is because we had one positive and one negative. That would have messed up the sign. Anyway, so you might not have flipped it. You might have just gone from here to there. Still correct. Either or, cosine squared plus sine squared or sine squared plus cosine squared is equal to 1. So I applied P1. That got me to here. And then I had negative tan divided by -1 times 1. Negative divided by negative gave us a positive. And then tangent over 1 is just tangent. And that's how you do it. Hope this helps. Bye.